Yeah, so a study was conducted to investigate the effectiveness of hypnotism in reducing pain. Results for randomly selected subjects are given the accompanying table. The values are before and after hypnosis. The measurements are in a centimeter on a pain scale. Higher values correspond to greater painful level. Construct. So this one said construct. So this one gave you a 95% confidence. So it gave you the confidence level this time. But I could work back and find alpha if I need to. For the mean of the before and after. Does it appear to be effective? So there are different ways that you can run a test for this one. We can say, is the pain level the same before and after? Is it greater than before and after? So there are different types of tests that you could run for this particular case. What I'll do is I will do a test just to determine if they're the same or not. So are the differences equal to 0, or the average of the differences equal to 0 for the population, or are they not? So I'll do a two-tailed test. But once I find the confidence interval, I could actually go deeper into like whether or not they work, whether the pain is bigger or less, based on the confidence interval. But I chose two-tailed because of the fact that the confidence level was 95%, so alpha would be 0.05. Because the confidence level is 1 minus alpha if it's a two-tailed test. Obviously, there were different ways that you could do this, and technically all are fair game based on the question. So let's do the confidence interval first. Then we'll find all this piece, test statistic and all that stuff. So I already input all the values into my calculator. I put the befores in L1, and I put the afters in L2. And because I'm going to do before minus after as my differences, I'm going to go L1 minus L2, right? So you scroll up so that you highlight L3, press enter, and then L1 minus L2, and it does my differences for me. So I'm going to go and collect all the information first. So let's go to the interval. So let's do T interval, because it's a T situation. Data. My list is L3, because that's where the differences are. Frequency 1, confidence level was 95%. That was given to me, so 0.95. So let's calculate that. So, let's write that down. 0.69, write that, 0.69, I'll round to 0.69. 0.69 to 5.56. So what this is looking like to me, these are all positive values, right? So that means that before pain should be greater than after pain, because the differences and their average is all positive. There are no negative values here. So positive numbers imply that the first number is greater than the second number if I'm taking the difference. So if I'm taking the mean or the average of these differences and they're all positive outcomes, that should imply that before is greater than after. So this is looking like hypnotism might work. It looks like the pain level before hypnotism is greater than the pain level after. Let's run a test and see. I'm doing a two-tailed test. I could technically do right-left if I want, but we'll do two-tailed just to make it easier. Well, let's go, and I'll just go straight. Actually, if you want, you're not asked for it this time, but if you do want X bar D, the mean of the differences, 3.125, and then the standard deviation of the differences is that, and you have 8 matched pairs, right? So it does that for you too. But let's go back to that test. Let's go T-test. Let's find the test statistic. So again, it's data. And again, this is always going to be 0 because you're comparing the two. It's always going to be compared to 0. The list is L3. I'm going to do a two-tailed test. Frequency is 1. And then calculate. So let's copy that down. My test statistic is approximately 3.03. What was it? 3.036. And then my p-value was 0.0159. If I round properly. Let's do the critical value just in case. The critical value, I'm going to do inverse T, so second bars inverse T. my area. So again, my alpha was 0.05, but with a two-tailed test, we got to cut that in half. So 0.025 degrees of freedom with 7. So my critical value is negative, positive and negative 2.365. Minus 2.365. Okay. Two-tailed tests have two critical values always. I know that it's two-tailed because it's not equal to one-tailed would have an area in one tail. Two tails would have an area in two tails. So let's see. Based on all this, I can go to my conclusion. All of them actually come to the same conclusion. So the p-value is less than alpha. This doesn't contain 0. The test statistic is not in the rejection region. So all of them is in the rejection region. So all of them come to the conclusion of rejecting the null hypothesis. Rejecting the null hypothesis. So if I'm rejecting the null hypothesis, I say that there is sufficient evidence. I'm rejecting the null, so there's sufficient evidence to support the alternative. So sufficient evidence to support the claim. And what does the alternative say? In this particular alternative, it says that there is a difference between before and after. So to support the claim that there is a difference in pain level before and after hypnotism. Now, based on the fact that it's two-tailed, I'm not going to say that there is sufficient evidence to support the claim that before is greater than after, unless I'm doing a left-tailed test or right-tailed test or whatever, but depending on how you do your differences. I could say that the pain level is more than after because of the confidence interval, but that's, I'm not always going to have that. I could change the type of test that I want depending on, you know, what kind of conclusion I want to come to. Do I want to know if the pain level before is greater than the pain level after? Then maybe I would change this now to a different type of test. It all depends on what I want and where, you know, etc. So it looks like in this case, hypnotism is working for pain level, which is cool. What you have been doing, you have been running tests for a single population proportion. You have been running a hypothesis test for a single population mean where sigma was known and sigma was unknown. You have been running a test for 2 population proportions and comparing them, right? You have been running tests for 2 independent samples for means where, remember, we decreased the amount of different scenarios just to sigma 1 and sigma 2 unknown and not assumed to be equal. So those are the situations that you have done thus far for hypothesis testing. Now what we are going to do is a hypothesis test, HT hypothesis test for 2 means, but we have dependent samples. So as we said, like they're matched pairs, so husband and wife, before and after, left arm, right arm of a single person, you know, they are matched pairs. So the first thing I want to talk about is notation, new notation that you haven't seen before. You have, let's start with the sample. So N represents the number of matched pairs, okay? So it's not necessarily sample size, it's the number of pairs now. X, D, actually I should say what is D first. So D, lowercase d, represents the differences between the pairs. So I'll show you what I mean with example, but differences subtraction in mathematics. X bar D is the mean, I should say sample mean of the differences, or the mean of the differences from the sample. S subscript D is the sample standard deviation of the differences, or it is the standard deviation of the differences for the sample. Mu subscript D is the population mean of the differences, or it is the mean of the differences for the population. So And then obviously, well, you're not going to really see sigma d, but if you did see sigma d, that would be the population, standard deviation of the differences, or the standard deviation of the differences for the population. So I hope you guys have your calculators. We're going to use it. But first, let's look at an example. Here's an example. So remember, you guys are going to have a combination of different types of hypothesis tests. You have to determine which one it is based on just reading your word problem. It's all word problems. So is it one sample? Is it two? Is it proportion? Is it mean? Are they independent? Are they independent? Is sigma known? Is sigma unknown? You got all these things you have to think about. Listed below are the numbers of words spoken in a day by each member of 6 different couples. They're couples, right? They're couples. And typically with couples, you have matched pairs. The data are randomly selected from 2 columns, blah, 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 in Appendix B. Use a 0.05 significance level to test the claim that among couples, males speak fewer words in a day than females, and then construct a confidence interval, which we'll do both of them. We'll just find all the pieces. That's a funny claim, right? So first of all, you have your males and the number of words that they speak per day, and then females and the number of words that they speak per day. So let me show you what some of the terminology means. So D, if I were to extend this, if I were to extend this and create another row, D, the differences, this would be the differences or subtraction. I'm not going to have space to write this, but between male and female. So the way that you calculate your differences is very important. So I always like to write a note. I'm going to do male spoken words minus female spoken words. Things might change if I were to do female minus male. The way that I take the differences matters. So I'm going to write that down to remember what I did. So I'm going to do male minus female. That means that each one of these is going to be this value minus this value, and whatever that is. This value minus this value, whatever that is. This value minus this value, whatever that. This minus this. This minus this. This minus this, right? That is going to affect, or how I take the differences is going to affect my hypothesis. Now, let's do the differences first. I'm going to show you a trick in the calculator to find them. So let's go to our calculator. So hopefully you guys have it out. And you could do it, obviously, you could subtract each of those values, but if you want to, but I'm not going to do that. I'm going to use my calculator trick. So I have to input both of these, data values into my calculator. So obviously we're going to go to stat and edit because I'm going to input stuff, input data. So I'm going to put it into list 1 and list 2, and then I want to remember where I put which. So I'm going to label, so my male's going to be in L1 and my female's going to be in L2. So L1 for male, L2 for female, which means that I'm going L1 minus L2, male minus female. So here's your, unfortunately, we have large numbers. So male, so first, 15,684, my first. 26,429. 1411. 7771. What's the next one? 18. 876. 876. 15477. 14069. And then the last one for males is 25,835. 25,835. So L1 is all the male data. So now I'm going to scroll over to L2 and input my females there. So females, I got, or I have, right? I should say I have 24,625. 13,397. 338, 338, 17,791, 12,964. Obviously, this is what's next? 16,937, 16,255. One more, and 18,667.